very much. I'm using some old school technology to keep track of time. We're sitting here in an old factory. Could be like a scene for a horror movie where you're chased by a serial killer. I do think there's a serial killer out here, and that's AI. I predict most of us will not do the same work that we're doing today. I say 3 years from now. I get a lot of skepticism about that. But maybe 5 years tops, life will be very different. And I think maybe for people like the violin players in the beginning, those will remain. They're real kind of like creative jobs. But I think we as computer scientists have maybe committed suicide a little bit by going into agile, breaking our work into kind of like, like little stories that we pick off a board and then we kind of like implement them. And that is exactly the work that will be automated first. So in some sense, we dug our own graves. Sorry for not being upbeat. Anyway, and in some sense, that is a good thing, I think. Because what are we as developers really? We are kind of an obstacle between the user and the thing that the user wants to achieve. And that's just a temporary thing. Like, in some point in time, we were necessary to take what the user wants and implement it. But I think with AI, what that will enable is that the user can build their own apps. They can do their own work, and that will make us obsolete. So maybe your product manager will remain because they can talk with the user what they want, but the act of implementation will disappear. And this is my vision for what I want to build for the future. Here on the left, this is, I think, what we're all familiar with. There's like CPUs, then there's a virtual machine that abstracts from those, and then we get nice slogans like "write once, run anywhere." And then on top of that, we have a programming language. That's where a lot of our time is spent, where we write code. And then we want to have reuse. We don't want to write everything from scratch. So there's like repositories where we have reuse software. Now, there's also not that many developers. But this is still a huge market. But now let's look on the right. And this is the future that I have in mind. Is there will be a lot of different models. You see this already, right? There's an enormous competition going on in models. Of course, there's like OpenAI GPT, but there's also Anthropic's Claude, Meta with Llama. There's the European ones with Mistral. But all these models are slightly different. And so just like we had run once, or write once, run anywhere, you also want to have like prompt once, run anywhere. And you want to just, like the model should be something that's irrelevant. It's just the underlying thing that does the execution, but you shouldn't be programming directly against that. So on top of that, and that is what I will talk about today a little bit, is I'm envisioning this neural computer. So instead of having like, a virtual machine or a digital computer, you will have a neural computer. And that neural computer needs to be programmed as well. And we need a programming language that normal people, normal users, end users, can use to specify what they want the computer to do. And so I call that a reasoning language. And then on top of that, you also, again, you want to reuse code that people write. And so there needs to be a repository. That's what you see there. And the nice thing is that there's if we take that market and say these are people that know how to do simple formulas in Excel spreadsheets, which is really the the current end user programming framework, and there's 1.5 billion of those. And I think if we can eliminate developers and have users directly implement what they want, we will have a better world. And maybe for us, it will be great, right? Because maybe we can learn to play the violin and have some fun instead of like sitting behind the screen all day. I don't know if that's fun or not. All right, so let's give a concrete example. Let's ask this question. Sorry, it's spring in the Netherlands, and I'm not used to all the different like plants here. But let's ask this question here, and it looks like a simple question, but it's kind of like a little bit of a convoluted question. So how many Bitcoin do I get from selling 1 kilogram of gold, and how many Microsoft stock can I buy with the proceeds? Right, so this is a question that the user might have. So they go and say, oh, here, let's get, like, do some planning poker. Let's get, break this down into tasks, and then it gets implemented, and 5 weeks later, they have the program that can do that. So let's ask ChatGPT to do this, and it gives us a nice outline. You have to find the price. You have to find the price of gold. You need to calculate how much Bitcoin you get from selling 1 kilogram of gold, etc. But then it gets worse. Then it's like it's been to a party and is still like a little bit stoned out of its mind because it's just hallucinating stuff, right? It's just saying, oh, okay, what is it here? Like the current price of gold is 60,000 kilos or $60,000 per kilo. Well, a few days ago, it was nearly 80,000 kilos of gold. So it just hallucinates its answers. And then, even though the calculations were right, all the numbers were wrong, and then it says like, oh, sure, make sure to check all the values when you do this yourself. Now, this was then completely useless, because the whole point that we asked the AI to do this was that we don't have to do it, and now it says that we should do it. Now let's see how I think I envision this. And we asked the same question to this virtual neural machine, and it's like how many Bitcoin can I get for 1 kilogram of gold, and how much Microsoft stock can I buy? And now what you see is that you get a natural language description with little snippets in the square brackets, those are little snippets of code. And that, like, if anyone that has ever written an Excel spreadsheet should be able to understand this, right? Like, to get the current price of Bitcoin, I need to search the price of Bitcoin, and let's call that B. And then we need to search for the current price of gold. Let's call that G. And then we need to do some math. And then moving on to the next part of the question, we can look up what the closing price of the Microsoft stock is, etc., etc. Now you can imagine that anyone that asks this question can understand this explanation. It's a little bit like literate programming, right? And in some sense, the model has generated this code from natural language. But this is not code, this is not Python or Java or JavaScript. This is a program in the language, the programming language, that I envision normal people will use. Now, this is one of the things I think that a lot of people have a little bit of a wrong expectation of AI. We're really trying to make AI work in a zero-shot setting, where it's like, okay, I want to ask it a question and it should be correct in one go. I think that is not how things work. And I think that's also the downside of a lot of our current systems. Let me give you a very concrete example. If you're using a regular programming language, say Java, and you make a mistake, the compiler will tell you, oh, here's an error, right? Like, oh, you used a Boolean where you had to use an integer. But there's no way to have a dialogue with the computer. When we deal with humans, we don't say, oh, you're wrong, and that's it. No, we have a dialogue. So what you want, I think, also normal users, they will want to have a dialogue with the computer. So you shouldn't strive to make the answers correct the first time. You just should assume that they can ask something. And if I looked at this program, it was a little bit strange here at the bottom. There you see it's got the math, the gold for Bitcoin divided by Bitcoin, but the gold for Bitcoin was already divided by Bitcoin. So that looks a little bit convoluted. I don't know if anybody spotted that. So the user can say, hey, I think this is too complicated. Can you simplify it? And then the system talks to you, say, good, yeah, I can do that. So literally, you can, you're interactively creating this program together with your machine. And now, of course, I asked for how much can I get from selling 1 kilogram of gold. But that's not very useful. So now the user wants to define a function where it can ask create a program that can say, what if I want to sell X kilograms of gold? So now here, what you see there in blue, this is a function definition where the parameter is X. Okay, so this doesn't look at all like a function in Java or JavaScript or Python, but it is a true function. And maybe if you ever programmed in Smalltalk, you say, this is you have in Smalltalk, you can have the parameters can look like they are like natural language, but this is just a function definition that's parameterized by X. And now, again, the model generates the code in this programming language. So this is what I believe will be the new way of programming. And we are if you look at this, what can we do with this, right? It just solves the problem. There's nothing for us to do here. The end user can just do it themselves. All right, now maybe I didn't like this explanation too much because it was a little bit terse. And I can ask the model, well, can you rewrite the code a little bit to make it more clear what's going on? And then it gives you even more explanation. So this is refactoring, right? Normal users will want to do refactoring too, to make the code more readable. So all the techniques that we're using today will be used in the future, but not by developers, but by the end users themselves. All right, and then if I now strip out all this natural language stuff, and I just leave the code fragments, and I give it a name, so it's like a Bitcoin and Microsoft stock for gold, and it was parameterized by X. It gave me two values, namely the amount of Bitcoin I could buy for 1 kilogram or for X kilograms of gold, and how many Microsoft stock I could get for that. And then you get this program. So this is only the code fragments of that natural language program that I showed you. Now, if you squint a little bit, then this looks exactly like a Prolog program, right? Who here has ever heard about Prolog, logic programming? Maybe has used Prolog programming. Now, in the 80s, when people thought that in the first AI wave, or the second or the third, I don't know how many AI waves there have been, people thought that Prolog would be the language that would be used to solve AI. And there was the Japanese 5th generation project that was going to change the way we work and build new hardware. Same things that everybody is saying now, and Prolog was the language. Now, what's interesting is that Prolog is, I think, the language, but it doesn't run on parallel machines that people envisioned. It runs on LLMs, and these LLMs run on parallel machines. But still, the reasoning language, I think, is Prolog. It's a little bit different than Prolog, because in Prolog you can have run things backwards. Here, you run things forwards. That's why you have the little arrows. But ultimately, that's what I'm proposing, is that the new reasoning language will be Prolog, and it will be generated not by humans, not by developers, but by the end users themselves. All right, now let's go a little bit deeper into how I look at LLMs, because there's a lot of things you find online how LLMs work, but I think they're all too concrete and not abstract enough, or they give you some vague description of how they work. And hopefully I can give you a mental model that is useful for developers, where you don't need to look into the implementation of the LLMs, but you can build a mental model of how they work. So let's look at this example here, like what's the highest water level ever recorded at low bit? If we would solve this today, we would have some relational database with all the values. You write some SQL that looks like English, but it's not. But I want to show you here that this, I don't even, I did LINQ because SQL was too complicated, right? And this, I don't think that any normal user can write SQL like this. And this is why we need developers, but I don't think we should, it's too complicated. So the fact that we have to write SQL like this and have developers that know this, it's just sad. And it's, I think the SQL might even be wrong, I don't know. So let's just ask ChatGPT in this case, what was the highest water level? And it gives me the answer. Now, a lot of people confuse the fact that you talk to this model in English by thinking that it does natural language. But it's not really the case, right? Because this thing just deals with sequences of tokens, which are arbitrary, sequences of letters. And I can take that sentence, that English sentence, what was the highest water level ever recorded at low bit, and just say, highest level ever low bit. And that will give me exactly the same answer. And this is an interesting thing where there people are doing prompt compression, where you take a long prompt and you can compress it into a few things that is just token soup that makes no sense. It doesn't even look like English or Dutch anymore, and it still gives you the same answer. So for me, that shows that these models don't really understand. They're not intelligent, but it doesn't matter. I don't care about intelligence, artificial intelligence. That's the same, Dijkstra, famous Dutch computer scientist, said, it's not interesting to ask if a submarine can swim. Because the submarine can stay underwater longer than a human. It can do useful things. Some submarines can stay underwater longer. Some explode or implode. But it normally can stay underwater longer and swim better. But is it swimming or not? Who cares? And I think that's the same with AI. If you ask, is this thing intelligence or something? Who cares? It can do things better than we can, and so it's useful. So I think this whole discussion, whether things are intelligent, is just a distraction. All right, so now one way that people look at these models is as compressed databases. That's why I use this SQL table. Just like SQL has all the rows stored in the database, you take all the knowledge in the world, from the internet, you train the model, and then you compress that into weights. Once you have done that, you can give it a prompt, and it will give you an answer. All right, now let's get a little bit more formal, because what does it really do? Well, what the model does, it has this function here that predicts, given a sequence of tokens, it predicts the next token. And it does that by giving you a probability distribution of tokens, but that's not very interesting because it only gives you the next token. So what the LLM really does, it gives you a sequence of tokens, and then it gives you a distribution of sequences of tokens. Then you get a longer conversation. Now, these probability distributions, this is what makes a lot of computer scientists really nervous, because we like concrete answers. We like precise answers. If a predicate returns, if we write a test, it should return true or false. And we get nervous when it says, well, if I have the probability of this token, well, the probability of what is 0.2, and the probability of the is 0.035. ooh, this is fuzzy, makes us uncomfortable, which means that if you're uncomfortable with uncertainty, you're not suitable for the world of AI. And I think I speak to so many. Yesterday, I've tweeted something about some new programming language that Don Syme from F# was involved in, and then a lot of people are answering, no, programming languages should be precise. If that's what you think, then you're you can go home and you're out. You have to embrace uncertainty in this new world, because that's how these models work. Traditional machines were also uncertain, by the way. If you use floating point numbers, they are uncertain. There's all kind of uncertainty inside the machine. You have a network, 2 packets come in. So there's a lot of uncertainty already, except that we don't see it or we don't want to see it. All right, now, here's some super nice math. And this is called big step operational semantics, but this is the mental model that I want to leave you with, what LLMs do. And this looks like a bunch of Greek symbols with horizontal lines, but let's explain it in English. So what an LLM can do, and the Q here is the prompt, is the question. So the LLM can decide non-deterministically, randomly, probabilistically, whatever word you want to use, to stop generating new tokens, right? Because it should at some point stop, because it doesn't keep generating new tokens infinitely. So it can either stop generating tokens, or it can generate the next token, just get one randomly using this next function, and then it recursively takes that token, appends it to the prompt, generates a remainder of tokens, and then it takes the token there with what it generated and returns that as the answer. Right? Now, this is the mental model how these models work. You don't need to understand anything about transformers or attention heads or whatever. This is a purely adequate mental model of how LLMs work. And then, you see that it's recursive, because on top of the horizontal line there's LLM, and at the bottom there's LLM. And you see that there's Q and Q extended with T. So these AI folks, they're a little bit crazy. They call that auto-regressively. But it just means you build a sequence of things recursively. So that's really all there is. All right. I have just a few minutes, so let me close down with 2 things to show you that the mental model of an LLM as a database is wrong. So let's ask another question. What is the current water level in Lobit? And if you ask this, the model will say something like, oh, sorry, I apologize, I don't know. And so what do you do? Well, why is that? Because the model had this compressed world knowledge, and at some point there was a cutoff date, and it doesn't know anything beyond that date. All right? So now what you can do is you can give it extra information about the current state of the water level at Lobit. It's a little bit, this one is a little bit older. And I also changed the question a little bit, I want to know the water level in the city where the Rhine enters the Netherlands. So this is now the model, in its weights, has knowledge about the geography of the Netherlands. So it knows that the Rhine enters the Netherlands at Lobit. And then it uses this extra information to calculate the current weather. So this is how you can expand the model's knowledge with new knowledge that is not encoded in its weights. And probably, if you have ever done anything with LLMs, this is called retrieval augmented generation. And you probably felt like, oh, retrieval augmented generation, I'm doing something cool. Anybody here has used RAG? Good. Now, what does RAG do? It says, well, the model has a finite context, so there's finite number of tokens I can feed to the model. I have an infinite amount of things that I want to feed it that are not yet in its weights. So what RAG does, it says, look, I need to swap in the right information into that finite context of the model. Now, this is nothing more than virtual memory. So if you have ever done some operating system course, or you you are system administrator of your Unix box, RAG is nothing more than virtual memory. So it's nothing special. So that is why in the beginning, when I showed the Java stack and this neural computer stack, everything maps one-to-one. Even though that the computers, the CPUs are a little bit different, all the other concepts are the same. So RAG, just virtual memory. And let's given the time, I'll skip some of this, but I'll go to the end here. And this is the kind of thing here where that was I went through this really fast, but you don't need to know that, because all what I wanted to say there is that there's this one-to-one correspondence between traditional computers and these neural computers. So traditional computers has a RAM, and the models have context. Virtual memory was RAG, ALU in the CPU, that is tool use, the LLM is the branch predictor, and the control unit is the reasoning engine. So there's a one-to-one correspondence between the traditional computers and the new computers, but the big difference is the way you program them, the level of abstraction that you program them. Here it was us, and here it's them. And there's no room for us anymore. So with that, I'm done. And enjoy your last few days as a developer.